All right, so there are 50 questions on the paper, and let's look at the time you're given, 12 noon to 1:15. So you have 1 hour and 15 minutes, okay? So you have 75 minutes to do 50 questions. So if we think about having a minute a question, that's 50 minutes gone, okay? And we're left with 25 minutes. And that's enough time for us to preview the questions before we start to answer and then review after. Okay, give or take 10 minutes, give or take 5 minutes. Okay, so you want to make sure that you take note of that and you have that in your mind before you go into the exam. Okay, so let's get started. Before you watch the rest of this video, please make sure that you have done the entire paper on your own and you're now checking your answers with me as I do this. All right, so the first couple of questions usually always start off with something about measurement or SI units. So question number 1 says, which row shows the quantity with its correct SI unit? Okay, so length in centimeters. We're going to go through each option and make sure that it makes sense. Rule it out. So a better strategy than just, zoning in on whichever one pops out at you is to make sure that you can rule out all the others and you know why. Okay. So we know that okay, let's just escape. Okay. All right, so we know that length is not measured in centimeters, but meters, so no. Mass is measured in kilograms, not grams. Time measured in seconds, and if the other one doesn't work out, then we know that our answer will be C. Weight in pounds, okay? Not in the Bahamas. This is not the SI unit we use. We use the metric system. This is US customary units, okay? Pounds go with inches and feet, and we don't use that here, so that's a no. So our answer is C. Okay? Yep. And I'll leave it there for a second. And we do the next one. Okay. Which graph correctly shows load and extension for a spring stretched beyond its elastic limit? Okay, so we know that if a spring follows Hooke's law, then we're looking for a directly proportional relationship between the load and the extension. That is a straight line on a graph. If that's not happening, then that means the relationship between the two variables is no longer directly proportional, and so our graph will start to curve. So we know for sure that A and D are out because those are linear, straight through and through. Okay? What about C? Okay, so C says that we gradually increased our load and extension, and this tells us that okay, so remember, if we see our graph increasing, then that means that as the load is getting bigger this way, the extension is also getting bigger this way. Okay? When a spring is stretched beyond its elastic limit, it means that no matter how much load we put on there, the extension is going to stay the same. So if this is the extension, we see that even though the load is increasing, the extension is not. It doesn't go beyond this point. Okay? So this here is our answer. Okay? I'm going to clear the screen after every question to move it up so you can pause and check your answers anytime you feel you need to. Okay, number 3. A recent report noted that SUVs were more likely than a car to topple over when turning a corner quickly. What is a possible cause for this? Well, an SUV is a much taller object, so its center of gravity is going to be higher than that of the car. Okay, so our answer here is going to be B. B. Okay. Number 4, an astronaut takes a building block to the moon, that should say, where acceleration due to gravity is less than on Earth. Where acceleration due to gravity is less than on Earth. Okay. Which property of the block will change? Okay. So let's remind ourselves what these relationships depend on. So we know that density is equal to mass over volume. Okay. So we don't have a change in either of those. So that one is out. Mass is constant everywhere you go. So that's a no. Oh wait, hold on. Okay, that question. We're missing an answer here. That should actually be neither of those. Well, no, that should be neither of those. That should say weight. That's what depends on the acceleration due to gravity. Okay? Yep, sometimes we have mistakes. Happens. Of course, that will be worked out for you. So you just choose the best answer and move it along. Okay, which graph shows how the volume of a fixed mass at constant pressure varies with its temperature in Kelvin? Okay, why did they tell us Kelvin? We have to remember that when we're talking about the gas laws, we're talking about the absolute temperature, not in Celsius. Okay, all right, so fixed mass at constant pressure. So this is the gas law formula that does not include pressure. Okay, and we're looking for the one that includes volume and temperature. Vt. Well, that would be Charles' law. Okay. V1 T1 is equal to V2 T2. Okay, that's Charles's law. Okay, and this is a directly proportional relationship. Okay, in order to keep this ratio the same, if one goes up, the other must go up as well. Okay, so we're looking for a linear graph. And we're looking for one that has a y-intercept. Okay, that's going to be that one. Why is it not A? Well, remember that volume can never be completely zero, okay? Once a gas has reached absolute zero, which is the temperature at which, the volume at which it has the temperature 0 degrees Kelvin, then that is the lowest volume that it can have, okay? Absolute zero. That one could be a little tricky, okay? So you got to remember two things. You have to remember that if the formula looks like this, you have a numerator, denominator, a fraction, ratio, then that corresponds to a directly proportional relationship. So that rules out C and D. Directly proportional, we know we're looking for a linear graph, straight line. But then you have to remember something else about Charles' law, that volume cannot be zero. Volume of a gas cannot be zero. Okay? All right. Which inclined plane will most likely make it easier to push a loaded trolley from the ground to the top of the plane? So this is a question about mechanical advantage of an inclined plane. Okay? The mechanical advantage is given by the ratio of the height to the length of the ramp. So we can work out that for each one of these, mechanical advantage for this one is going to be 2. 2 over 1 is 2. This one, mechanical advantage, length over height, 2 divided by 0.75 is going to give us 2.7. This one over here is going to give us 4. And finally, this one, 4 divided by 0.75, gives us 5.3. Okay, so the biggest ratio is this one here. Okay, so D. Okay, and last question on this page. Which physical quantity is calculated by the product of mass and acceleration? Remember, product means multiply. Multiply. So what is equal to mass times acceleration? Well, that would be the net force on an object. And this is Newton's second law. Cool. Yes. 2.7. This one over here is going to give us 4. And finally, this one, 4 divided by 0.75, gives us 5.3. Okay, so the biggest ratio is this one here. Okay, so D. Okay, and last question on this page. Which physical quantity is calculated by the product of mass and acceleration? Remember, product means multiply. Multiply. So what is equal to mass times acceleration? Well, that would be the net force on an object. And this is Newton's second law. Cool. Right. Number 8. Which velocity time graph best shows the relationship between velocity and time for a parachutist jumping from an aircraft before the parachute opens? Okay, so this part right here is giving us a specific condition. Okay, a parachutist jumping from an aircraft before the parachute opens. So when the parachute is closed, then that means that person is in free fall. And free fall means that they're falling under the influence of gravity only. And that means that they are falling with a constant acceleration. The acceleration due to gravity, 9.8 meters per second squared, or you might use 10. Okay? This is the important bit of that here. Constant acceleration. On a velocity time graph, the slope gives us information about the acceleration. If the acceleration is constant, then that means that it is increasing by equal intervals in the same amount of time. Not to be confused with no acceleration. Remember, no acceleration means that it is moving with constant velocity. So that would look like this portion of the graph. This is no acceleration, flat line on a VT graph. Constant acceleration means that it is increasing steadily. So we're looking for a linear graph like this one. This graph over here says that it increased steadily and then stopped, okay, and continue to travel at constant speed. Okay, so you sped up until you got to a certain speed and then you carried on at that speed. These two are out because these are not showing linear relationships, okay? These graphs do not show constant acceleration. This shows varying acceleration, okay? All right, number 9, which variable is a vector quantity? What does the word vector mean? Vector quantities have both size and direction. That means that we can ask ourselves how much and which way.